Good morning, Physics 184. It's your boy, Aiden. And today I'm going to be explaining to you something that's really near and dear to my heart, the right hand rule. Okay, now this is something that's incredibly important when you're dealing with magnetism and circuitry. Right? This is super important. Now, let's rotate over. You can see here, I have a hand. This is my right hand, the hand that's on the right side of my body. This is the one I grab all the doorknobs with. Um, this is the one that holds the mouse, as you can see here. This is the one that I pull the shifter with in the car. This is my right hand. Now, here's what we got to do. You'll note that the right hand rule has three components, and it involves your pointer finger, your middle finger, and your thumb. You can see my thumb on the other camera. Okay. So these three components right here, as you can see, are the entirety of the right hand rule. These two fingers down here, they're not important. You can cut them off. Cut your fingers off. No, don't do that. This right hand rule involves these three components. The first component is the direction of your charge, right? Where are your electrons moving? Your V, this is your V, or your I, honestly. They'll both be moving in the same direction. So in the case of the right hand rule, it doesn't matter. But bam, or you got your one direction. This is the way things are going. You'll have an observation point. Point towards your observation point. Let's say ours is it's up here. Or sorry, it's right here. It's right here. Our observation point is right here. So we're gonna point. Here's our. This is the way our charge is going. This is the way our observation point is. And these two fingers will tell us everything, because the third finger is then locked upwards. So if we have our charge going this way and our observation point is this way, then our field will travel upwards in this scenario. So let's start with an example. As you can see here on the screen in front of you, we have a current loop. So it goes in a couple different directions, and then we have C, A, and B, a couple different points here. So let's start with point. Let's draw a box, and let's only look at what is in the box and ignore absolutely everything else. Seriously, ignore everything that isn't inside this red box on the screen here. So we have our observation point. We have observation point A, and we have the current. So the current is going in this direction. All right. We come down here, and A is in that direction. So let's take our middle finger, our pointer finger, and point it in that direction. All right, as you can see on the side of the screen there. And then let's take our other finger and point it in the other direction. So we're looking at that, which means that B is this way, right? Our thumb. And my thumb is pointing, boom, into the screen. So in this scenario, our B vector is pointing into the screen. Now we've done that, and that's wonderful that we've done that. And I'm so proud of you for doing that. Now let's try up here. What direction is our current going? Well, it's going in the same direction. So we're going this way. But look, our current's going the other way. It's going up. So now we're looking like this, right? Which means our thumb, when our thumb points, and you can't really see it that well, but the thumb is pointing towards me, which means it's flipped around, and it's the opposite of what it was before. Now the charge is coming out of the page, into my face. It's hitting me in the face. I have a nosebleed. It's awful. And we can do the same thing again here with C, because C's getting a little funny. C's getting a little funny. We're getting a little crazy here with C. Our current is now going upwards. We're pointing upwards. All right. And our B is over there to the left. Our B, our observation point is over to the left. So now we're doing this. You see what I'm seeing? I know you can see it. So what way does our thumb go? Our thumb is going back towards me. I'm getting another nosebleed in this direction. Now, if you think I'm full of it, I would understand that. But this is actually a homework problem. This is 3.2.4 on the homework. And you can tell that I know what I'm talking about because um, I got the homework right. Thank you for attending my lecture on how this works. I hope you enjoyed. I hope you learned a thing or two or three because I showed you 3 examples. So I hope you learned all 3. But I would be okay if you kind of got bored. I would understand that. So thank you and have a great rest of your day.